So we're going to use these rules to graph our solutions. And I'm going to show you how a compound inequality just combines the two inequalities as one, okay? So these are both compound inequalities. This is an and compound inequality, okay? And a lot of times the way that I remember that it's an and problem is that it makes a sandwich, okay? It makes a sandwich with that and in there because the variable's in the middle of the sandwich and then the solutions are on either end. So it's a sandwich. The solutions are the bread and the variable is the stuff inside the sandwich, okay? And then this is an or problem, okay, which means that you can just put two answers, two solutions on one graph. And so it's either this answer or it's that answer. So that is how I think and see whenever we see compound, which means two inequalities simultaneously on a graph, okay? So the solutions are all real numbers that are greater than -3, greater than -3, and less than 1, okay? Because what this really means is that x is in between -3 on the left side and 1 on the right side. So x is bigger than that -3. It's greater. The symbol is backwards because the variable is not in front of it, okay? But then it's less than the number 1. It's going to be smaller than that. So because x is between them, okay? Because x is between them, you actually graph the area between them. So this symbol would be open because there's no equal at -3. This symbol would be open because there's no equal to. And x represents the numbers between them. Okay? So this is x. Okay? This area is x. The x is the number is greater than -3 because it's eating that x, so it's more than that, and then but it's less than that -1. Okay? So this you really just translate down. You put -3 on the lower end, you put 1 on the upper end, and then you put the x in between them as the shaded section. That's like doing arrows, except they connect, okay? So then this one is actually easier because it's just two different. So the solutions are all real numbers that are less, okay, because that's a less than symbol, than -1, or greater than or equal to +1, okay? All right, so really, ORs are pretty easy. They're just two answers at the same time. We're just going to put them on the same graph. So, less than -1 means an open circle because there's no equal. Excuse me, that one. And less means to the left. Okay, because numbers less than are to the left. And then greater, I said it wrong. You'll see why down the road. Greater than or equal to means we fill it in. Because there's a line under there. And then greater means we go to the right. So OR problems are really nice because really it's just, you just look at them separately, but they just happen to be on the same number line, okay? So you still have to use the same rules for your arrows and your points, but that sandwich does look a little bit different because it goes from the smallest to the largest. So -3 is the smallest, x is in between, and 1 is the largest. So your number line actually looks very, very close to the actual solution, the way that it's written. Okay? So now we want to take that, and let's apply that to, let's see, there we are. right, so why don't you just try this one real quick. It's an or, so that's nice. It's just in between them. So go ahead and try it yourself, and you can just compare yourself with mine. Okay, so it's just two different ones on the same graph. That one's filled in or closed because it has the equal. This one points left because it's less than. That one points right because it's greater than. And X is leading in both of them. Okay, so now let's solve a little bit. Or let's talk about solving. All right, there's a bunch of rules here, so we'll have to kind of take them in pieces. All right, so here's the original and here's equivalent. And all we're doing is we're solving them to show that you'll get the same solution, so you just want to solve it like normal. So it's a lot like the solving equations. Whenever you do the left side, you have to do the right side. So the rules are adding. Whatever you add to the left, you have to add to the right. Let's use a different color. Subtracting. Whatever you subtract from the left, you have to subtract from the right. And then we'll talk about multiplying and dividing. So let's first do these. So if I add 7 here, I have to add 7 here. And so X is less than 11 as my solution, because then I can graph it, okay? I take away 3 here, so I can take away 3 here. Be careful when you combine those. That's actually a -4, okay? So again, it's just like equations, all right? Except now we have to keep one extra thing in mind when it comes to multiplying and dividing. So let me scroll that down. Let's see. All right, so now let's look at multiplying and dividing. So you have to be careful. If the numbers are positive, so if you notice right here it says multiply by a positive, okay? So if the numbers are positive, then you just work it out like you did adding and subtracting, okay? So to remember, to get rid of a fraction, you can use its reciprocal. That's the multiplicative inverse. That reciprocal will cancel that out. 10 times 2 is just a 20. And we're done. It looks the exact same, greater than here, greater than there. Okay? Same thing for division. If you're dividing, and it's a positive number that you're dividing by, nothing's going to affect it. You just divide both sides out. That cancels. The symbol stays the same. And it's a 3. Okay? So those are very similar to the adding and subtracting. It is when we get into these negatives that our rules will change. Okay? So this is where we have to be careful. So when we multiply by a negative, it changes things up, okay? That negative reverses our symbol, okay? This negative will reverse our symbol. So that's what you have to keep in mind. So since there is a negative right here, it's going to reverse that. Since there's a negative right here, it's going to reverse that. So that's what you want to keep in mind. That's why I'm writing it and outlining it in red so that it stands out. Okay? So, since in order to solve, we would have to we could multiply this by a -1, and that would cancel out this -1. Okay? But if I multiply by a negative on both sides, since I'm seeing this -1 show up on both sides, it will actually flip the symbol, okay? So the negatives will cancel, you'll get X. This turns into a -17, but that negative on both sides makes it go the other direction. So X is actually greater than -17, okay? So the same thing here. We are dividing a number out to solve it. And when we divide by this -9, Okay, you have to see it show up on both sides. That's one way you can tell when you're supposed to flip it, is that when you solve, if you see it show up on both sides, -9 here, -9 there, that's when you know, oh, I need to flip that around. These negatives mean that that would flip around. So we cancel and we do get -5, but instead of greater than or equal to, it flips around to less than or equal to. Okay? So these are the two that you really have to watch out for. Maybe you want to, like, you know, star them so that you remember that if you multiply or divide by that negative, I'll just leave it, you will flip that symbol as you're solving. So then we have to remember to combine that with all of the other parts, like the compound inequality, the greater, or excuse me, the or and the and. And so we have to keep all of that in mind as we're working, and then as we build on that for our Algebra 2. Okay?